In this video, we're going to look at graphing the absolute value of a function, given the graph of the original function. And so for the purpose of this demonstration, I'm just using a graph that resembles a parabola, so that original function x. And we're going to graph its absolute value in this form, in the form y equals the absolute value of f of x. So what this basically tells us is that if y is the absolute value of anything really, I mean whatever's inside the absolute value brackets there, that means that the y value of our transformed graph can't be negative. Okay, so the resultant graph is going to be at or above the x-axis. So let's have a look at the positive values of f of x. So of our original graph. So any point on the curve above the x-axis, so if I just pick any sort of random points, if I take the absolute value of that point, well, it's positive anyway. So nothing's going to change. So the original part of the graph above the x-axis is retained with no change. However, what happens then with the negative part of the graph, as in the part of the graph that's below the x-axis? So if I say pick the point, say here, and I took the absolute value of this point. Now this point's negative, at least in the y dimension. Take the absolute value of that, it's going to be basically reflected in the x-axis, and it's going to end up here. I'm trying to get it sort of somewhat accurate. That's not to scale. Okay. And likewise with any other points that are below the x-axis, and you can pick any point you like, any ordinate, doesn't really matter. If you take the absolute value of that, it just reflects it in the x-axis. So basically quadrants 3 and 4 get reflected back the other way to quadrants 2 and 1 respectively. Okay, so I guess just to sort of cut a long story short here, I might just draw the resultant graph. So you're reflecting this part of the graph here under the x-axis, kind of like folding it over the x-axis, or sort of in the x-axis, sort of to the positive part there. So it's going to look something like that. And I might just draw the resultant graph in red here, even superimposed on the original graph. And it did state earlier that the original graph above the x-axis doesn't change. So you end up with a kind of a strange looking graph there. This is the absolute value of f of x. And notice also what happens here and here. It is no longer smooth. In fact, any sort of graph that involves some sort of an absolute value transformation or a composition involving an absolute value almost always results in a sharp corner or a sharp vertex. So this is no longer smooth. So the original function is a smooth curve. The resultant function, after the absolute value is applied, is no longer smooth. However, it is still continuous though, in the sense that I can draw the resultant curve without taking the pen sort of off the page or off the whiteboard. Okay, thanks for watching and wishing you all the best.